Welcome to this explainer. Today, we're diving into a concept that completely changes how engineering teams balance rapid innovation with service reliability. Look, if you've ever been in a room where developers are pushing to ship a new feature right now, while operations teams are practically begging to freeze deployments because the system is unstable, well, you know exactly how painful this balancing act can be. Today, we're breaking down the secret weapon that organizations like Google use to solve this exact problem: error budgets.
Here is our roadmap for today. 1. The 100% uptime myth. 2. What are error budgets? 3. Why error budgets matter. 4. Google Cloud case study. And 5. Best practices for SRE.
Section 1. The 100% uptime myth and why perfect reliability actually kills innovation.
This brings us to a really uncomfortable question. Should engineers just stop deploying features after repeated outages? It's that classic tension, right? Developers want to ship code fast, and operations teams demand stability. Every single engineering organization faces this. Business leaders want faster feature delivery, but customers expect highly reliable services. Because every software release introduces some level of risk, these goals often seem totally at odds. So when things break, should we just freeze everything?
Well, pursuing perfect reliability often comes at the cost of innovation. It's a harsh realization, but aiming for 100% uptime isn't just unrealistic, it actively prevents business growth because it halts new feature deployments. It sounds like a great goal on paper, sure, but complex distributed systems simply cannot realistically achieve perfect availability. In fact, pushing from 4 nines to 5 nines of reliability can cost an organization exponentially more money. We're talking sometimes 10 to 100 times the infrastructure cost just to save a few minutes of downtime a year. If your goal is 0 failures, you're going to swing between two extremes. You either ship too aggressively and break things, or you avoid change altogether and totally stagnate. Neither works.
Section 2. What are error budgets? The mathematical approach to reliability.
So if perfection isn't the goal, how do we manage this risk? It all starts with your service level objective, or SLO. This establishes the baseline reliability target your customers actually expect. Now, to get an SLO, you first need a service level indicator, or SLI. That's your actual measurement, like latency or request success rate. For example, your SLI might measure the latency of a checkout button. And your SLO is the promise that 99% of those clicks process in under 200 milliseconds. It's the line in the sand. It says, if we drop below this level of performance, our customers are going to be unhappy.
And from that SLO, we derive the error budget. This is simply the acceptable amount of unreliability a service can experience while still meeting its SLO. Rather than aiming for an impossible perfection, error budgets give you a practical, measurable framework. It essentially acknowledges that failures will happen, and it gives you a precise threshold for exactly how much failure is okay.
The formula here is beautifully simple. Error budget equals 100% minus your SLO. Think of it exactly like an allowance you get to spend on taking risks with new deployments. If your SLO is 99.9%, your error budget is 0.1%. That tiny fraction is your allowance. As long as your service's unreliability stays within that 0.1%, your dev teams can keep deploying new features at a healthy, rapid pace.
Notice how this math plays out in the real world. If you promise your users 99% availability, you have over 7 hours of wiggle room a month. But push that to 4 nines, 99.99%, and you have less than 5 minutes of acceptable downtime for the entire month. This really puts into perspective why you shouldn't just arbitrarily promise perfect uptime. You absolutely have to align your SLO with what the business actually needs, because a smaller error budget directly limits how fast you can safely push changes.
Section 3. Why error budgets matter. Balancing speed and stability.
Here is the magic of the framework in action. Let's say your monthly budget is 43 minutes. In scenario 1, the budget is intact. You've only used 5 minutes of downtime this month. Great! Releases continue, frequent deployments happen, and fast innovation hums along. But in scenario 2, a string of bad pushes eats up all 43 minutes in the first 2 weeks. Boom! The budget is exhausted. Instantly, feature releases pause. The focus shifts entirely to root cause analysis and paying down technical debt until the budget resets and reliability returns to acceptable levels.
This approach completely eliminates subjective deployment arguments. It replaces opinions with data-driven decisions. Without this, questions like, should we release this feature today, just turn into a political fight between dev and ops. Error budgets strip the emotion right out of it. It creates a shared responsibility model. Developers get the confidence to release rapidly when the budget is healthy, and operations gets the peace of mind knowing there is a hard, measurable brake pedal if things get too unstable.
Section 4. Google Cloud Case Study. Error Budgets in the Real World.
To make this super concrete, imagine a highly scalable modern SaaS platform running on Google Cloud. You've got your stateless containers in Cloud Run, relational data in Cloud SQL, and caching and memory store all sitting behind a global external application load balancer. But even with top-tier managed services, things can and will go wrong. Networks have blips, bad code gets merged, queries run too slow. That's why cloud monitoring and cloud logging are foundational here. They're continuously capturing metrics straight from the load balancer and evaluating them against your defined SLOs.
Now, if this organization sets a 99.95% SLO, they have exactly 21.6 minutes of monthly error budget. That number is a hard boundary. If a bad container image gets pushed to Cloud Run and causes 15 minutes of downtime before it's rolled back, well, you've just spent over 2/3 of your monthly budget in one shot. Cloud monitoring triggers the alert. The business now knows, objectively, that they need to tread very carefully for the rest of the month. Reliability work is immediately scheduled ahead of new features, and a post-incident review kicks off to ensure that specific failure doesn't happen again.
Section 5. Best practices for SRE and adopting the framework.
If you're ready to adopt this in your own organization, here are the steps to build a successful program. 1. Define your SLIs and SLOs clearly. 2. Automate your availability measurements and continuous monitoring. 3. Conduct blameless postmortems during outages. And 4. Link deployment policies directly to error budget consumption. That last step is absolutely crucial. Your error budget cannot just be a passive metric. It has to actually control your deployment policies. You also have to remember this isn't about pointing fingers. There's a huge misconception that error budgets are just a tool to punish employees. They aren't. They are meant to guide engineering decisions. And hey, this isn't just for massive tech giants either. Small teams can absolutely use this framework to build confidence in continuous delivery.
As we wrap up this explainer, I want to leave you with this really powerful thought. Innovation should be fast, but never faster than your users can trust. Reliable platforms aren't created by avoiding change. They're created by managing it intelligently. Perfection is rarely achievable. The real goal is predictable, measurable reliability that lets you move fast and innovate without burning through the goodwill and trust of your customer base.
So how does your organization decide when reliability should take priority over feature delivery? Take a look at your current processes and really ask yourself that final question, because implementing error budgets might just be the objective answer you need. If your strategy relies on shouting matches between dev and ops or just trusting gut feelings about system stability, it's time to let the math do the talking. Thank you for joining me for this explainer, and I hope this helps you build faster, safer, and smarter.